Welcome everyone. I don't know if you guys can see this, but I have a visitor here. This big boy, Vader. He's been trying to get love from Daddy for like all week, and he decided he wanted to come up and say hi to me right before the stream. That's why I started a few minutes late. Oh, too funny. Hello, lovers. What am I gonna do with you? All right, gotta go. Come on. He really doesn't want to. Say hi to everybody. He's not very. He's a big boy. He's probably good 20 pounds. All right, let's. I gotta do some work. Hey, Paladin. Oh, nice to see you. I'm glad you made it. Hope we get a few more people showing up and saying hello. Let's see. I gotta make a few adjustments here. I think that works. Oh, silly, silly cat. All right. For those of you returning, for those of you that watch the stream when it's not live and are coming back, we're at a really good point here. And I almost called this done last episode. And I quickly realized, oh, I don't have a way to fasten the two halves together. I don't have any mounting at all for this. So, and I know there's probably some things I wouldn't mind getting done. Let me look at this real quick here. As my thoughts are to do some rounding. But I can do some minimalist. Doesn't have to be big. I think I'll take, let's see what an 1/8 inch radius. Whoa, let's try an actual 1/8 inch here. That looks nice. And then that can be like a virtual sharp in the middle. Yeah, we'll do it that way. Make it a little bit prettyful. Do that with the bottom. What's going on here? Oh, is it because of that edge is gone now? Yeah. Oh, and I can't grab the inside one. Should be able to. All right, let's change that. View, display. Nope. Hide show axes. Temporary axes. That's what I want. Yeah, we'll do it that way. That'll make it much nicer. Maybe we can turn those off. And then I'll have to do that to the other one since I'm changing how I'm telling it to. Mirror those around. Save all. Let's go ahead and open that one and do the same thing to it. Should remain the 1/8 inch. Oh, guess not. And I'll leave these open because I got to do some modification on them anyway. And, oh, didn't throw an error that time? Oh, I see. Okay. Took fatten and mirrored. Okay, gotcha. Or arrayed it. Okay, very good. All right, let's look at the top. And what I'm looking for is a way I think I know what I want, but I'm not 100% sure. Whoops. I'm thinking, I want a hex. Oh, Jesus. Socket. Socket head cap screw head size chart. That's jeez. Oh man, could they made that any worse? I had my machinist handbook with me. I think I left it at the last place I was working at before the COVID hit. No, I want this dimension here, and I'm not seeing it. D. Ten, 32, or 24. Huh. Dog. Not worried about that. This is what I want. 0.19. So I could actually go. It's about 3/4 of an inch thick. So if I go with a quarter 20, I think that'll work. Top. The only thing is I didn't leave a lot of this is going to be a little bit tricky. Well, this sucks. I didn't really make this to where I could go all the way around. Because my initial thought was just putting a hole right through. Damn. Okay, this may be a little bit more than I thought it would be. Not really sure what the best way to do this is because I have so much material here. Let me verify. It is hot in this house. Oh, half inch. Okay. if I could do, since there's, no, that wouldn't work. That wouldn't work very well. Engine buckle mechanism would be kind of cool. Let's see. I gotta figure this out here. It doesn't have to be super tight on there. These are what's the problem. I may have to reorient the rotation on that. Because I don't have a place for a screw at all to go in here. Because I want one here and here at least. And then here, all the way around. I'm thinking, let's do this. Let's do, man, oh man. This is really, I'm gonna have to build this kind of differently because I've got a rounded edge on this side. Whoops. This is, okay, all right, I want the bottom. What I could do, no, I really can't do that. I was thinking of a type of membrane, but I really don't want to be digging with all that shit. It's just for airflow. It doesn't have to be super sealed or anything. But I do need to maintain the integrity there. So, let's do this. Let's go with, yeah, let's try this. Let's see, I think I want this. Nope, straight. Let's see, I've got, here, let's try this. Here. One, two, three. Let's do it this way instead. Okay, so if I want a hex, I need a 0.375. Wait a minute, what was that dimension here? 0.19, so it's probably literally 0.1875, or that's the max. I don't see any dimensional tolerances, but that's okay. Oh, no, I wanted to do 0.25 would be the diameter on a quarter. And that way I don't have to have it really long if I do it the way I'm thinking here. All right, so 0.25, oh, that's still pretty big. Means I would at least have to have a 1/2 inch diameter. Yeah, let's go with 3/8. We'll go with the number 10. I think that'll be better. All right, so number 10, we're gonna go, oh, oops, come on. Oh, that's pretty tiny. Yeah, 0.5. And then we'll make these all the same. All equal. And then what I want to do is we're going to extrude that. What's the pitch diameter on it? Oh my God, can you please give me all the information I need? D. I don't want metric, I want, here we go. I need small d. Oh, I was looking at the wrong thing anyway. So small, okay, that's the, okay. So a 1/4 inch hole would be a nice slip through. And the max head is 0.303 to 312. Okay. All right. That's okay. This is better information. All right. Let's see. So 0.312. 0.075 is the nominal. And I'm going a 1/2 inch. So actually, yeah, those can be. No, yeah, that's right. 0.5 is what I want. Okay. My goodness, help me. All right. What is going on here? Oh, let's see. I got to have this and this tied down. I do, yep, okay. Yep, let me fix that, make sure all those are tied down properly. Oh goodness, it's gonna make me do it this way, huh? Now, trick that I learned back in designing enclosures is to extrude this stuff with a draft so that it's constantly in contact with the surface as it's going. If I just did a cylinder straight up, it wouldn't have any type of contact with the rounded surface. But if I extrude it like this, there's going to be plenty that'll basically merge into and become part of this wall thickness here. Coincidence. And you'll see what I mean in a second. Oops. All right, so let's extrude this. And we're going to go this way. And I want to taper that a little bit. Draft outward. 3 degrees is fine. And then I think I want an inch. Here we go. Oh, that's not much. Okay, let's do 5 degrees. There, that's better. So what that gives me is a lot more material up here than down here. Now, if I was doing this as an extruded part, this would be designed very differently, but it's kind of the same principle here. Kind of. All right, let's see what that does now. That connects up to that point. So I might need to make that 3/4 of an inch. Let's do that. Okay, I'm happy with that. And then what that allows me to do, see, I've got a nice sunk part there. I can go ahead and fill it all this stuff and make it kind of nice. Let's go ahead and do this part. And, whoa, hello. Let's do, oh, it doesn't like that. I'll probably have to do that after, maybe. All right, let's keep rolling along. Come on. Go this way. Yep, that grabs it all. Now, the only thing I gotta make sure is in the assembly that it doesn't interfere with this, with that clearance there, because if it does, then that's not gonna be fun. Nope. that a little bit thicker. Not very happy with that. Oh, for Pete's sake. Let's see if I can bump that up. No, I can't. Okay. And I take this off. Let me try something here. So I need more material there. And I want that off. Got to make sure I select the right thing here. I'm sorry, guys. I was not prepared for this not looking as great as I was hoping. That looks a little better. Then I can add this. That's better. I like that. Smooth some of this stuff out. Make it look kind of snazzy. Now this should be able to be milled out of a block of whatever. Let's see. Can I do? That's going to be a mating surface. So having it flat like that is fine. So now let's do this part here. And we're going to have, no, I don't want a tapered tap. Let's just go with a hole. Hello, a hole. Want counterbore maybe? Binding head. Socket heads. There we go. Number 10. It is normal slot length. In condition through all, that's fine. Let's see if I can pick these. Oh, hello. Oh, wait. What? Why is it giving me a slot? Oh, I don't want a slot. I want that's what I want there. I misunderstood it. Well, need that to be, that depth to be a lot deeper. What's head clearance? Oh, to countersink it. Uh, Actually, that's not a bad idea since I got all that thickness. So the head clearance, the thickness on that is, that's showing the head. So let's do 0.05. Actually, I want more than that. Nah, that's fine. Mhm, mhm. That way I can counter it. All right, let's see what that looks like. So far, so good. I could actually get away with that being a little bit smaller. What's the diameter of this? Because that does not look like it's, I want this to be a slip fit. And then it be going into a machined. Well, if I make this out of plastic, I'll use a PEM insert, which if you've seen my my 6 GPU design, I used a lot of those in there. If I make this out of aluminum, have it machined out of aluminum, which should be okay. These might have to be separate pieces. I'm not sure. I would have to consult with a fabricator on that. But anyway, point is, I can have it directly threaded in, machine thread. Let me see. Sometimes I like to do this just to see what it's. This is not flowing for me. Do I want? Do I want this to have a little bit of? Yes, I do. I don't like sharp edges on non-mating surfaces, and it's not to where it's coming into the round. So basically, this will be machined, and then these will be machined out after the fact. I need to get a hold of oh, it follows the rim. Okay, that's fine. That's weird that I have more material here than I do. That's a little odd, but I'm okay with it. Now, yeah, that's nice. That looks much better. Let's go back to there. This keeps me from having to drill. I really would have liked to have been able to go all the way through and put this feature on the inside where this material is here, but it would have been a little more difficult. This gives me the option to later on, if need be, modify the whole part from a molded, a injection molded part. I can modify this to fit that, and these are more useful in that regard. Let's see here. From here, that's pretty good. That should give me enough clamping down force. Now I just got to mimic this pretty much on the in the opposite way, but I don't have to go as thick. So let's see. So from here, we're going to do pretty much the same thing. Center line is going to be here. Yeah, we'll go ahead and do. And then after this, we'll have the, this is the fastening to each other part. And then I want to look at motor mount option. I think that should be included in this design. And I'll probably have to have vibration suppression. Oh shit, what are those called? They're like just rubber feet that vibration isolation something. Again, I can't remember the name. All right. I made those 0.5. That's right. Nope. 0.5 diameter. Make all of these the same. I think I can do it this way. Nope. It doesn't understand what I'm trying to do. I can do it this way. Equal. Oh, come on. Uh, there's a lot of, or well, I don't know about a lot, but there's a few. And designers out there, or I don't know if I would call them designers, but people that use SolidWorks and even put out videos on tutorials on how to do SolidWorks. And then they don't go through and make sure all the mates are selected. Now, that's super important because when you go back through and you add a mate and it influenced the size or the position, like for instance this, I've got the size locked down, but it's only coincident to this point and this arc. So it's basically a tangent type connection. So that means anywhere around that is a valid spot that it could be. So people will leave it like this. Something comes through and you do some modification and the rules that tell it where to snap to are interrupted by something else that you do, you're just going to have a huge mess. So it's always good to lock it down. If you can't move it, if you can't stretch it, then you're golden. Only move it when you want to, not when something influences it that you didn't account for. Just, it's always a bad idea. And I know a lot of them do that to do some, just to do quick sketches and stuff, but it's just super bad habit. Or they'll lock it into empty space that doesn't mean anything. So when you try to bring it into an assembly, super frustrating to find out if something's off, and it most likely always is. I had a company that I worked for where it was just a notorious thing, where you had to go through and spend a good 2 to 4 hours going through every little piece to find out what was broken. And more often than not, it was because something was just locked into place but wasn't mated to any plane or any origin or anything like that. It was just free floating, and that's just a huge no-no. Also a major pet peeve of mine. All right, let's make this 3/8 of an inch, and we'll make sure that looks like it hits where all the pieces that I want. Yes, that's fine. Oh, honestly, yeah, that's not what I want to do there. Can I get the same? Honestly, if I did that, I would have to do it that way. All right, we'll leave it. I don't like because it's gonna look a little funky, but I think we'll be all right. All right, let me look. This was, this is okay, 1/4 inch. I think I did 1/4 and then 16th, I believe. I'll double check that. I may have done a quarter. No, I don't remember. All right, that got all of those. And then let's verify this one. Yep, it's an 1/8. Ah, balls. Oh, stop. Select what I want or what I tell you. No, it did it again. All right, it's not really liking me today. For the most part, this would be okay as almost as it is, as a mold injection part, just because of the cylindrical nature. Now, the inside, I couldn't have sharp edges here. I would have to make those a little bit more rounded or chamfered. Uh, all of this would have to be modified, and these pieces here, actually, this would just have to be a piece that I design separately and then insert because the uh, because making this like this, it would require some expensive tooling. We're talking 50, 60 grand because they would have to have inserts. And that's if they could even do it. So I would definitely make these a very easily machine or a different kind of part. I would make that a separate piece, and I would probably thin this out a little bit because yeah, even if they could do this, then the shrinkage on this would be far significant, and it would be done cured sooner than something like this and all the other walls. So this would definitely have to be a piece that I would have done separately and then inserted in after the fact. Just some FYI stuff. Probably stuff you'll see if I get finished with this and then I come back after some funding comes through or whatnot, or I'm able to do some prototyping, and I have to do some redesign work based on, collaboration with a manufacturer or whatnot for, hey, what's the best for this? Then you'll definitely get to see that once that comes into play. Yeah, okay, that's what I thought. Just making sure. Let me do the hoops first. So this is actually going to be on this side. And let's see, I have from here to here is what distance? Nope, evaluate. Looking at roughly a 1/2 inch, a little bit more than, barely a little bit more than. So if I go with, let's see, 0.51, and I made these 3/8. So that's 5/8, right? No, 0.375 plus 0.5 is 0.875. Should be 7/8, right? Verify that. Yeah. So if I do 3/4 overall, minus 0.51. So if my hole is 1/4 of an inch, that still leaves me a little bit of clearance. All right, so that's what I'll do. So I'll only need 3/4 inch tall threads, and that will be just fine. And we're going through this first, or this side now. Oh, oops. So these I think I'm going to go ahead and go with the threaded. I can always come back and modify it if I have to do an insert. I don't need that. I want a blind. What? Why is it asking that? Bottom tapped. Just a tapped hole. Thank you very much. In condition, I want blind, and I want it at least 3. No, 3/4 overall. So point. Oh my goodness, 0.25. Ooh, I may have to bump it up so it doesn't. Yeah, let's see what that looks like, because that may not be exactly what I want there. No, this is fine. This is what I want. It looks like my graphics card needs an update. I noticed that right before we were going to start, and then that's when Vader came up and was wanting some love before I got started. Oh, goodness. 1032. Yeah, I think that's more common. And that should hold everything in place. Okay. That looks pretty good. Now, let's see what it looks like together. Hey, that's not bad. Oh, that's going to be a son of a bitchin' problem. Crap. That won't work. I forgot about that. Yeah, there's no way to get to that. I may have to figure that out a little bit later. I may have to rearrange how everything is. I may have to rearrange these exhaust ports to be half, kind of like this is, and then like, or I may have to have just two larger ones. Yeah, I'll have to come and look at that because I like the way this looks, but it's just obvious it's interfering. There's no way you can get a screwdriver in there to put these in. Unless, I mean, I could have these made where they thread in. If we look at this, this is the part that's insert. This could be threaded. Of course, then this would have to change a little bit differently because, just because the design, this would have to be chamfered, and then that way I can get a thread across there. That might be a better way to do it. That way, because all these are just exhaust ports. I mean, I could even create a basically another mounting plate system that screws into the main body. I'll look at that. That's something I'll have to look into and see how I want to do that better. Because that's just adding more pieces and parts. But it would save, this can be a slip fit piece that's just held in place by a plate that, a thin plate that goes right up against there and just snugs it in and holds it in. Then your just order of operations would be different. You want to take this all apart, you have to take these out first. So just basically disconnect uh, the exhaust port, then you can go all around and pop it open, which that's probably what you'd want to do anyway. That would be, yeah, I think that would be the better way to go. That would make it easy. And it could just be this plate that comes around like that, just because I wouldn't be able to do a circle there, because then that would be in the way of the plate. I'm gonna have to think about that. Or I can just modify this to be, to have a loop out on each side or something. So and then a threaded hole right there. That would work too. In fact, that might even be easier. Have it crisscross pattern. Yeah. All right, that's good. Save all. Rebuild and save. Let's make sure there's no errors. That's great. Oh. All right, so far so good. Now, that takes care of that part. Now how to do this. Let me think here. Here's the thing. The way this needs to be done, honestly, well, you can actually set it like this, and this would be can be down. These can be rotated down, so that you're just basically taking air straight up, and you don't have to have it follow like a path in a loop down. So, I mean, I can assume whatever, but I want a mount that's universal. Well, kind of universal anyway. So, but it also includes the alignment and vibration absorption. Let's see, can an increase in internal pressure for any reason call a failure of the device? If, well, I'm guessing I did some early calculations. I mean, and this is a really great question. Normal atmospheric pressure is like 14.2 or 14.7 pounds per square inch. This thing, based on, depending on the material, I mean, we're talking almost a half inch, I believe, thick plastic and or aluminum. And using 1032 screw threads, I mean, we're talking withstand probably easily 90 psi, maybe even a little higher than that. I don't foresee any amount of pressure in that range going into this system based off of what it's going to be pulling the airflow from. We're talking, you know, basically high volume, high velocity fans pulling hot air away from mechanical equipment. Um, Now, and it's based on my experience, it's pretty steady stream. You know, once it's confined, it's only going to go so far before it just kind of dissipates out. You know, if you get a fan and you blow it on yourself, the further away you walk, the faster it dissipates. Now, when you enclose that, you're just maintaining that constant pressure when it's coming like right out of the uh, right from the fan blade, because that's where it's going to be at its strongest. And then there's just a very short distance where it's the strongest, then it just starts dissipating because it doesn't have nothing confining it. The other side to that is these openings. There's 4 of them at 1/4 the size of this main. So this should allow a lot of airflow out as much as going through. So should be under a constant pressure. So if there is something happens, I, I honestly couldn't tell you what it would be. Somebody taking a blowtorch and heating up air before it gets in there, that's going to increase the pressure as well. If it gets over, I'm going to say 90 psi, yeah, this thing probably will fail. But again, I don't, I don't, I don't, I can't conceive that this would get anything over 20, 25. Maybe close to 28, 30, maybe 2 times uh, normal atmospheric pressure. But any cooling needed? No. Actually, I have plans to uh, try to increase the rate by increasing the velocity by adding heat to the system. So no, there will be no cooling needed. My based on my understanding of gas and how it behaves, if we are using it for work, as energy is converted from the pressure and velocity to this mechanical, okay, what that should do is decrease the temperature because it's losing energy. I believe that's my understanding. I think that's how that works. Because if you increase the energy by adding heat, you're going to increase the amount of energy each molecule, each gas molecule has, so it's going to want to go faster. I hope that makes sense. A very rudimentary way of stating it. So I hope that makes sense. Why is everything in the, well, that kind of makes sense. It's featherweight, set lightweight to resolved. Well, I wanted it to do it for all of it, but okay. Oh, that's because I turned the shaft and it freaked it out. Okay. Schooling needed. Okay, let's see here. Let me think about this for a second. Now I could do. How would I strap this to something? Honestly. Because I made that around on the bottom. I mean, I almost would just use some really massive U-bolts and drill a couple holes and then turn it whichever way. Like if it's mounted on a wall, obviously it would turn this way, and then you'd install the motors on a plank coming out. And if it was like this, I mean, you could still put it on a wall like this and have your exhaust coming up in through there. And then the motors would get turned 90 degrees. And then you would have basically just a block of wood with some rubber grommets fastening to whatever side of the building you're on. It wouldn't be hard to mount this. I would advise against putting it on outside because I don't know how weatherproof these engines or these generators are. So that would be an interesting thing. You know, I'm almost not wanting to design a mounting system for that simple reason because there's plenty of hardware out there. And it really depends in the environment that it's going to be put in, what it's going to need. I mean, there's some pretty easy ways to do this. I think I would have to consider if there is some wrong way to do this. Yes, I remember science class. Well, I'm guessing it may be a little bit longer for me than it has been for you. So, and I didn't get the opportunity to take physics in high school. That I went to a very small private school, and high school, like 12th grade physics was just not an option, or even 10th or 11th. So that's all stuff I've learned by just reading and reading and reading because I wanted to learn. I did take biology though in high school. That was quite fun. DNA is still today one of my most favorite subjects to look into and to read about and learn. All right, I can't think of anything else that I really want on here. Sorry if my voice went down. Uh, my my microphone, I kind of pushed it away. I need to get all these. I really wish it wouldn't do that because that's very annoying. That's probably, come on, whatever, I'm not gonna fight with it. Did I crash my system? Yeah, it's not gonna. I really wish it wouldn't load lightweight. I don't like that. That's very annoying. Assemblies. Oh, that's why. Number of components exceeds 500. Yeah, based on all the these little vanes and stuff, airfoils. Yeah, I think I'm at over 508 components in here. And that's not including any screws that I put in. Yeah, I think honestly, you know what? Let's look at this. I do want to fix this. And since I'm not going, yeah, since I'm not going to design separate mounting systems for whatever field or whatever field this could go in, let's fix this little stumble here. Let's get this to where it is doing what I want. So what I'm thinking here, could make it direct part, but I don't like the way those do that. Oh, what's that diameter? And why is that doing that? That's what I want. This diameter. Let's fix this real quick. Why is it 2.68? I don't think that's 2.683. 2.683 is the diameter of that. Okay, so I'm going to do a sketch on that plane. Wait, what? What? Why is it doing this? Oh, it's already in sketch mode. Okay. Jesus. Those the same. And they're going to have a diameter of 2.683. And I want these to be sample. Okay. So I need it to be outside of this. So I want a hole here, 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 and here for threading. Let's see. All right, I need to cancel out of this because that's not the right way to do it. And I think I'll use some smaller holes. Oh, nope. I want 632, 0.44. That should be fine. But I want that to be let's make this 0.37. Oops, 0.375. And I want it to be threaded. Yes, okay. Positions. And boom. Actually, I'll do 4. Okay. I need to put these circles back in so I know where my limits are. And then I can mirror these to the other side. They're going to be equal and they're going to be for construction. 0.2683. No. 2.683. Oh my goodness. All right. Now I want an offset. Whoops. Sketch. Point. So if I do 3-inch, let's look at that. Let's try that and see what that looks like. I like that. I think that's going to work just fine. This one, we're going to have equal and also for construction. Jesus. Do 3 inches. And then these will be connected to this diameter. All right, and then I want my, I should be able to do the same thing over here. Oh, whoops, I don't want that. Oh, come on. So I want that to be 45. 90, and then this will be collinear with that. This will be collinear with that. Oh, excuse me. Wait, what the hell's going on? Oh, I see what's going on. Okay. And we'll do the same thing over here. Oh, wait, no, you gotta put these in place now. Probably was a quicker way I could have done this, but oh well. I muted myself when I sneezed, and I forgot to turn it back on. I'm sorry, guys. I was in the zone. I apologize. God, how dumb. Is that why everybody dropped me? Oh, fudge muffins. This needs to be connected to that. No, 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 no. I can fix this. We'll make that work, and then we'll do tangent, tangent, and tangent. Yes. Hopefully you can hear me now, yeah? Lord have mercy. You can see my mouth moving, but nothing's coming out. It's okay, I was probably just showing some frustrations. Alright, now hopefully this does the same thing I was hoping for. I can cut that. Don't need that piece. Don't need that piece. Don't need this piece. Don't need this piece. And I don't need this piece. Now we can get this. And we'll make this 45 degrees. Perfect. Oh, my apologies. Goodness gracious. All right. Now I'm going to extrude that to this thickness and then array it. Because I don't want to do 4 of those. That's a pain in the ass. Okay, features. Extrude. Other way. Let's see. Can I say up to next? Really? No up to next? Up to surface. We'll go there. Boink. And then what we're going to do here is we're going to array this bad boy. Let's get a front look at the, oh, this way. This is the front. I guess it don't matter. Hide show, temporary access, 1 second. Oh, my apologies. I think that cat being up here got something up my nose. I don't know what it is. All right. See if we can finish this without dying tonight. I want 4 and I want it to be equal spacing all the way around. Yes. Boom. Done. Perfect. And then we're going to turn that bad boy back off. Hello. Where did you go? Oh my goodness. Okay. And then, let's see, this is the front. So these will be through holes. And I can just use regular pan head screws for just to make it nice and easy. Going to do, nope, not a threaded, just a hole. And I want it to be clearance, screw clearances, number 6. Through all is fine. And the positions are going to be on this plane, here, hello, here, here, and here. I think this is the easiest way to do it. Oh, no, why is it? I don't want it to do that. It made it a, I don't want it to be, yeah, there we go. Just a straight through hole. Pan hick and set right on top of that bad boy. That's what I want. There we go. Mucho bettero. And I still did it on the wrong side, but that's all right. It's a through hole. It doesn't matter. Honestly, it does matter because when you make the drawing, it's going to tell them to do it this way. And no, it has to be right. Can I go this way? Position. I want it to be on. Oh no. Can I tell it? And its sketch plane. I want it this sketch plane. Will that scream at me? No, it should not. Perfect. That's what I wanted it to do. On drawings, the reason I changed that is because this is the side going into the housing, and this is the side connect, and then your screw's going to go from this side through. When they machine this part, or however they make this part, if the drawing will indicate which plane I chose to say where to start drilling. For one like this, that doesn't really matter. But like if I had a counter bore on here, because I wanted to hide the head a little bit, then me selecting this plane would have the counter bore on this side, which is the wrong side. I need it on this side. So that's something else I always make sure, just in case if I need to change it, because with these little features and stuff, you can go through and change things pretty fast. And if I have the wrong plane selected and somebody else comes to do some modification and they just not paying attention select because they assume I did it right, then that could go through a whole horrendous thing of problems. So it's always good to pay attention. All right, so let's see how this looks. Now I only did the one, so now what's cool is point. Now all of those, see, I got my clearances. So basically everything will get attached, then these will get attached. Yes, I like it. I probably need to smooth that, make that a little bit bigger, but nah, I'm not going to. All right, now I need to do the same thing to the bottom. Put the same holes in there. Let's see here. This side. I did, shit. I need to double check the dimension. I forgot what it was. Sketch. 3 inches on, okay, for the center. Okay. Okay, easy enough. Hole. And I want it threaded. 632. Don't want it through all. I want it blind, and I want it 0.375, which will probably make it 0.38, which is fine. I really wish you would make the full thread, but I'm okay with that. That means if I have I can actually do a 3/8 inch thread. Some of it will be on the top, but enough will be engaged. At least a 1/4 inch of engagement, which should be fine. Okay, let's get these where they belong. On here, and we're going to do some circle. Go. Can I please get the center, please? Oh my God. Swear to God, sometimes this thing is just does not capture the moment. And now I'm looking down, making sure I'm heard. Now I'm just totally freaked out about it. I gotta double check the other one because I think those have the chamfer in it, which it really doesn't need it. Well, I'll have to look. I'll have to look and see here. 45, 90, go linear, and go linear. Now, I took those 632s, right? Yes, should be right. Okay. Now, I'm confused. Did I do that on? Ah, that's okay. That's for countersunk. I need to change that because I do not want it to be like that. Where is that sitting? Boom. I do not want that. Yes, that's how it should be. I forgot that was a default feature. All right, let's get this back. That's good. I believe that. Oh, no, I got to mirror it to the other side. That's right. Right. Oops. Nope. Right. Plane. Mirror. Ta-da. Done. All right, I can close that one out. That's good. Save that. I can close that one out. Yes. Uh-oh. What? I don't understand. I really don't understand why it's having a mate issue now. Just delete it. Yeah, I don't really know why it did that. The only thing I can think of here is that, let's see, because it's one and then I basically just arrayed it, that it's wanting to twist it as it arrays, so the constriction on that one hole is freaking it out. So we will, oh wait, what's this? Nope, that's right. So let me see if I can do this. this and we'll make that parallel. There, none of these will turn now. Perfect. All right, so we got all of that done. Great googly moogly. Those bearings are not, yeah, that's fine. Save that bad boy. That's a saver. Now, the one thing I might consider, you know what? I think I'm going to actually do it because I think it's going to need it. Is I'm going to have a chamfer on this side. Nothing irritates me more than trying to put a hose on a fitting where there's no like an ease of slip. You know, you have to fast lane it up, or you have to heat one and chill the other so you can work it on. It doesn't cost that much to put a freaking chamfer in there. Just make it easy on people. I think I want to do a 30-degree chamfer though. I think. Let me double check what that looks like here. No. That's too much. I want 60. Oh, Lord have mercy. There, that might help. That gives me about half a wall there. So there's plenty. I mean, if this will be good in application where there's a hose, and I may have to find out if this will fit a hose. Right now, it's for a PVC pipe. This outer dimension should have the same dimension as the inside of a 2-inch pipe, or an elbow rather, sorry. So depending on material used, this will change, which I can create different files for different things that are going to be used. Do I like that? Hello? Oh, helps if you type something different. Ooh, that's kind of nice. What happens when nope, I don't like that. I don't want that much though. Wow. Just very little. Ooh, yep, that's the ticket right there. A little bit of a slip and pop, and then if they use a hose, they can use a hose clamp. Excellent. Okay, that makes me happy. Almost looks like a miniature jet engine by itself. All right, let's see how that looks on the overall. Oh yeah, we're looking fabulous. And actually, this is kind of nice because I don't want somebody trying to take this thing apart with the exhaust connected. I just don't want it. Doesn't seem kosher to me. Now, there's other ideas that I've thought about where I could, as the development gets a little further along, one of my things is maybe putting some kind of a connector, like an elbow or a T connection, and then having these go to another, recirculate back around to the entrance so it can be a closed loop. I mean, here's the thing, there's all kinds of scenarios where you can utilize the energy from this, send it back through the system, chill it before it enters back into the mining area. I mean, if I can get the volume and the pressure and the velocity, these two units should give me, I think these are the 2400 apiece. Yeah, 2400 watt versions. So we're sitting at like 4800 watts. This is, you can do a lot of stuff with that. Assuming this works. I may find that I have to do some extra work with it, but we'll see. I mean, theoretically this should work. Now, whether it's going to move this much weight, I don't know if there's a compression ring inside the generator. It shouldn't, because if it's like an alternator, you can just spin it. So it doesn't take much effort at all to get it going or to get it started. So, well, I think we're going to call that designed, done, ready for prototyping. We'll call it that. Yeah, it's been a fun project. Now I got to figure out what I'm going to do next week. I'm not exactly sure. I have a couple ideas floating around in my head. We'll see what happens. So, I guess surprise for next week. I'm calling this one good and done. And thanks everybody for tuning in. And thanks to anyone that comes by and watches after it was live. I appreciate the support. And we'll see everybody next week. Same time, same channel. Thank you so much. I appreciate you guys.